Imagine, if you will, the entire sprawling history of our planet, all 4.5 billion years of it. Now let us compress that immense timeline into a single, understandable day of just 24 hours. On this cosmic clock, every second represents more than 50,000 years. It is a scale that allows us to witness the grand, slow-motion drama of our world's creation and evolution. This perspective is not just a scientific curiosity. It is a profound way to understand our own place within this vast, ancient story. Our journey begins at the stroke of midnight, a moment of unimaginable violence in creation, where the story of Earth truly begins. The clock strikes midnight. In the blackness of space, there is no Earth, only a swirling disk of gas and dust left over from the birth of our sun. Countless particles of rock and ice collide, drawn together by the relentless pull of gravity. Over millions of years, these collisions build upon one another, growing larger and larger. This is not a gentle process, it is a chaotic, fiery birth. A young molten sphere begins to take shape, glowing red-hot with trapped heat from its formation. This infant planet is a hellish world, constantly bombarded by asteroids and comets, its surface a sea of liquid rock. There is no air, no water, and certainly no life. Sometime around 12:30 in the morning, a truly cataclysmic event occurs. A protoplanet, roughly the size of Mars, careers through the young solar system and strikes our Earth with unimaginable force. The impact is so great that it blasts a colossal amount of molten rock into orbit. This debris, held by Earth's gravity, slowly coalesces to form our companion, the Moon. The collision tilts our planet on its axis, giving us the seasons that would one day shape life. The Earth's surface remains a turbulent ocean of magma, a world still being forged in the crucible of the cosmos. As the first hour of our 24-hour day unfolds, the relentless bombardment from space begins to subside. The planet's surface slowly starts to cool, forming a fragile dark crust of volcanic rock. But beneath this thin skin, the Earth's core remains a furnace of molten heavy metals like iron and nickel. This churning liquid metal core is incredibly important. It generates a powerful magnetic field that stretches far out into space, acting as an invisible shield. This magnetic field deflects the harmful solar wind, a constant stream of charged particles from the sun. Without this shield, any atmosphere or water would be stripped away, leaving our world barren and lifeless. The early morning hours are still profoundly alien. The air, if one could call it that, is a toxic mix of nitrogen, carbon dioxide, and methane, with no free oxygen to breathe. Yet something remarkable is about to happen. Around 12:45 a.m. on our cosmic clock, the constant rain of comets and asteroids which once brought only destruction now delivers a precious gift water. Frozen within these celestial messengers are the molecules of H2O. For millions of years they fall upon the cooling crust, releasing their water as steam. The steam rises, condenses in the thick atmosphere, and falls back as rain, beginning a cycle that will last for eons. This is not the gentle rain we know today. It is a torrential, planet-wide downpour that lasts for centuries. Water fills the vast, low-lying basins of the New World, and by 1 a.m. the first oceans have formed. But these are not the tranquil blue seas of our time. They are hot, acidic, and filled with dissolved iron, which likely gives them a murky, olive-green color. The young sun is weaker than it is today, yet the planet is kept warm by a thick blanket of greenhouse gases. It is within these strange, chemical-rich waters, perhaps near bubbling hydrothermal vents on the ocean floor, that the greatest miracle of all is about to unfold. At approximately 1 a.m., in the warm, primordial soup of the early oceans, a new kind of molecule appears. This is RNA, a simpler cousin of DNA. These molecules have the incredible ability to store information and replicate themselves. They are the first, tentative sparks of life. For the next hour on our clock, representing hundreds of millions of years, these simple replicators dominate. Then, around 2 a.m., a more stable and efficient molecule evolves, DNA. This double helix is a far more robust blueprint for life, capable of storing vast amounts of genetic information with greater accuracy. Life has found its permanent code. With the advent of DNA, the first true cells, prokaryotes, emerge. These are single-celled organisms, incredibly simple, with no nucleus to house their genetic material. For the next several hours of our planetary day, these microbes are the sole inhabitants of Earth. They are the only form of life on an otherwise empty planet. To a visitor, Earth would still appear utterly barren. The land is bare rock, the oceans seem empty, and the air is unbreathable. Yet beneath the surface of the water, a quiet, microscopic revolution is underway, setting the stage for everything that is to come. Life has gained a foothold, and it will not let go. As our 24-hour clock ticks past 3 o'clock a.m., a new kind of microbe evolves, one that will fundamentally alter the course of life on Earth forever. These are the cyanobacteria. They have developed a revolutionary new trick: photosynthesis. Using just sunlight, water, and carbon dioxide, they can create their own food. This process is remarkably efficient, but it produces a waste product. For these tiny organisms, this byproduct is simply something to be expelled. For the rest of the planet, however, it is a potent, reactive, and highly toxic gas. That gas is oxygen. For the next billion years of real time, a staggering 5 hours on our cosmic clock from roughly 3 o'clock a.m. to 8 o'clock a.m., these cyanobacteria work tirelessly. They spread throughout the oceans, forming vast living mats called stromatolites. All the while they pump out tiny bubbles of oxygen. At first, this oxygen doesn't build up in the atmosphere. Instead, it reacts with the iron dissolved in the oceans, causing it to rust and settle on the seafloor. This process forms the vast banded iron formations that we mine for steel today. The oceans are literally rusting, slowly changing from green to blue as the iron is removed. Around 8:30 a.m. the oceans can absorb no more oxygen. The gas finally begins to pour into the atmosphere. This is the Great Oxygenation Event, and it is a global catastrophe for the life that existed at the time. Oxygen is poisonous to the anaerobic organisms that have dominated the planet for over 1 billion years. They have nowhere to hide from this new toxic air. This event triggers the planet's first and perhaps greatest mass extinction. The life that had ruled the world for an eternity is wiped out, pushed into the shadows, surviving only in oxygen-free pockets deep in the mud or beneath the earth. The world is now fundamentally changed. The sky turns blue. The methane haze that once warmed the planet is broken down by the oxygen, plunging Earth into a series of profound ice ages, some so severe they may have covered the entire planet in ice, a snowball Earth. Yet from this crisis, new opportunities arise. The presence of oxygen in the atmosphere allows for the formation of the ozone layer, which shields the surface from the sun's deadly ultraviolet radiation. This will eventually allow life to conquer the land. And for the life that survived, oxygen provides a powerful new source of energy, paving the way for larger, more complex beings to evolve. The morning and early afternoon of our planetary day, from about 8:30 in the morning until almost 9 at night, is a very, very long time. For over 12 hours on our clock, life remains relatively simple. The great drama of the oxygen crisis has passed, and for more than 1 billion years, the world is inhabited by single-celled organisms, and eventually, simple, multicellular algae. Eukaryotic cells, cells with a proper nucleus, have evolved, which is a pretty significant step up in complexity. But from the outside, the planet still looks quiet. The stage is set, the atmosphere is ready, but the main actors have not yet arrived. It is a long, slow, patient wait. Then, shortly before 9 at night, something extraordinary happens. In a geological blink of an eye, the seas suddenly teem with an astonishing diversity of complex animal life. This is the Cambrian explosion. It's as if someone has thrown a switch and the quiet world of microbes erupts into a world of visible creatures. For the first time we see animals with shells, with legs, with antennae, and with eyes. Creatures with bizarre body plans swim through the oceans. There are trilobites scurrying along the seafloor, and strange predators like Anomalocaris, the great white shark of its day. Life has moved beyond the microscopic and has become big, active, and wonderfully weird. This burst of evolution continues throughout the late evening. Around 9:30 the first primitive fish appear, the first animals with a backbone. Plants, which have been tentatively colonizing the damp edges of the land for a while, begin to spread inland, followed soon after by insects and other invertebrates. By 10 o'clock, amphibians, descended from lobe-finned fish, crawl out of the water, becoming the first vertebrates to walk on land. The world is turning green. Great forests of giant ferns and mosses cover the continents, creating vast coal swamps that will one day power our own civilization. The air is now rich with oxygen, allowing giant insects like dragonflies with the wingspan of a seagull to thrive. As the evening wears on, life continues to diversify and conquer the globe. Around 1040, reptiles evolve, better adapted to a life on dry land with their scaly skin and shelled eggs. This leads to the rise of a new group of animals that will come to dominate the planet like no other. The stage is now set for the planet's most famous inhabitants. The air is warm, the continents are covered in lush vegetation, and the world is ready for the arrival of giants. The long, quiet morning is a distant memory, replaced by an evening filled with the sounds and movements of complex, magnificent creatures. Just before 11 o'clock on our 24-hour clock, the first dinosaurs appear. They evolved from earlier reptiles and quickly spread across the supercontinent of Pangaea. For the next hour of our cosmic day, representing more than 150 million years of real time, these creatures will be the undisputed rulers of Earth. They are an incredible evolutionary success story, diversifying into a stunning array of forms. There are the long-necked sauropods like Brachiosaurus, the largest animals ever to walk on land. There are armored beasts like Stegosaurus and Triceratops, and of course, the fearsome predators like the mighty Tyrannosaurus rex. The world they inhabit is very different from our own. The continents are slowly drifting apart, the climate is warm and tropical, and flowering plants have just begun to evolve. While the dinosaurs dominate the land, the seas are filled with giant marine reptiles like plesiosaurs and mosasaurs, and the skies are patrolled by winged pterosaurs. For hour after hour, minute after minute on our clock, from 11 o'clock until almost midnight, this is their world. Mammals exist, but they are small, shrew-like creatures living in the shadows, scurrying under the feet of the giants, their time not yet come. Then, at 11:39, with just 21 minutes of our day left, disaster strikes from the heavens. A massive asteroid, 6 miles wide, slams into the planet in what is now the Gulf of Mexico. The impact is 1 billion times more powerful than an atomic bomb. It triggers a global firestorm, colossal tsunamis, and sends a thick cloud of dust and soot into the atmosphere, blotting out the sun. The lights go out on Earth. Plants wither and die, and the food chains collapse. It is a swift and brutal end to an entire era. The dinosaurs, along with around 75% of all species on Earth, are wiped out. Their long and spectacular reign is over in a matter of moments on our cosmic clock. The Great Extinction Event clears the slate. The giants are gone, leaving a world of opportunity for the survivors. Among them are those small, furry mammals that had lived in fear for so long. With the dinosaurs gone, they emerge from the shadows and begin to diversify, evolving to fill the empty niches left behind. The age of reptiles is over. The age of mammals is about to begin. The final 20 minutes of our planetary day see the rise of the mammals. They explode in diversity, evolving into whales in the sea, bats in the air, and a huge variety of creatures on land, from tiny rodents to giant rhinos. Primates appear, adapting to a life in the trees. The world begins to look more familiar. The continents drift into their modern positions, and the climate cools, leading to the formation of the polar ice caps. This is the world that will greet our own ancestors. But their arrival is still a long way off in the grand scheme of things. We are now in the final minutes of the day. The clock ticks closer and closer to midnight. At 11:59, with less than 1 minute to go, the first hominins, our early ape-like ancestors, begin walking upright on the plains of Africa. For tens of thousands of years, represented by each passing second, they evolve. They learn to use tools to control fire, and their brains grow larger. But modern humans, Homo sapiens, do not appear on the scene until the clock shows 11:59 and 58 seconds. Our species has existed for just 2 seconds of this 24-hour day. Think of it. Everything we call human history, the building of the pyramids, the rise and fall of the Roman Empire, the Renaissance, the Industrial Revolution, the 2 world wars, the moon landing, all of it is crammed into a fraction of the final second. The entire recorded history of humankind, from the first cave paintings to the device you are using to read this, is a brief, final flash of light just before the clock strikes 12. Our magnificent civilizations, our art, our science, our conflicts, and our triumphs are a fleeting whisper in the immense ancient story of our world. So, what happens when the clock strikes midnight and a new day begins? For Earth, the story continues. In the distant future, the sun will grow hotter and brighter. In a few 100 million years, another hour or so on a new clock, the oceans will boil away. The planet will return to the hot, dry, and sterile world it was in its infancy. Eventually, the sun will swell into a red giant, engulfing the inner planets and vaporizing the Earth itself. Our planet's long and wondrous day will come to a definitive end. This long perspective begs the question, in our tiny fraction of a second, what will our legacy be? How will we choose to use the precious moment we have been given?